So hello everyone, this is lecture 78 for the mathematical physics. In the last lecture we were discussing about the differential form of Laplace transform, and I told you that if you have this kind of form then you can directly write the Laplace transform, that is minus 1 to the power n fns, and here n represent the differentiation and the order of that. So that's how you can do it. So let's discuss today about the integration form. So if you have LFT, means Laplace transform of ft as fs, then Laplace transform of 1 upon tft can be written as fs ds, and the integration s to infinity means this is some variable, and when you solve this and put the limit s to infinity, that will be your Laplace transform 1 upon tft. Now what is the use of this? If you take the L inverse of this thing, that will give you, means inverse Laplace transform of this will give you 1 upon tft. See, here is the application part, means L inverse of fs ds. When you integrate this, so whatever you are having, the inverse will give you 1 upon tft. So this is a very much used to us. Let's see how can we use this. Let's take an example. So we need to find the inverse Laplace transform of log 1 plus omega square divided by s square. So what we will do, we will assume in place of s just s dash, and just this we can say it bar also. So minus d by d s bar and log 1 plus omega square s bar square. So we need to calculate this. So let's see what we will get. So we'll get minus 1 upon 1 plus omega square s bar square minus 2 omega square s bar cube. We just take the differentiation. It is 1 upon, means log x is 1 upon x, then differentiation of this will give you this. 1 will become 0 and it will give you minus 2 omega square divided by s bar cube. Now solve this. This will be this. Now using the partial fraction we can write in this form this. Now this is a function of s bar, so we can write as capital F s bar. So see, if now you take the integration of this fs bar with ds and integrate from s to infinity, then you will again get this function. So now fs bar ds bar, when you represent this s to infinity, this will give you again this, because this is differentiation of this, means integrating will give you minus log 1 plus omega square by s bar square. When you put the limit s to infinity, at infinity it will become minus log 1, because this will be 0. So minus log 1 will give you 0, that means minus. Then you place s inside the limit, that will give you 1 plus omega square by s square. So minus minus will cancel out, it will give you plus again. So you will get again this. So you can write this, means this complete thing can be written as fs bar ds bar, and here fs bar is this value. So now you have this form. So the inverse will be 1 upon tft, and ft is nothing but inverse of fs bar. So fs bar we already have now, so we just take the inverse of this and write 1 upon t ft. So 1 upon t and ft is inverse of this, so 2 multiply 1 upon s bar will give you only 1, so that will give you, means 1 upon t outside, so this will give you 2 only, because inverse will 1 of 1 upon s bar. And inverse of s bar over s bar square plus omega square is nothing but cos omega t, so it will give you cos omega t. So this will be the inverse of this, and multiply 1 upon t, this will be your Laplace inverse transform of this function, log 1 plus omega square divided by s square. So I hope you get this, that how can we use this formula. Let's move forward. Try to prove this. This is the same we can do for this also, as we did here, 1 plus omega square. So you can do this. It will be 2 upon t 1 minus cos hyperbolic omega t. So try to solve this. Let's move forward. Now the convolution. What is convolution? So let's say we have some ft, and the Laplace transform of ft is capital Fs, and Laplace transform of gt is capital Gs, and we have some function hs, which is multiplication of fs and gs. Now inverse of hs, which is multiplication of this fs gs, inverse Laplace transform of hs is ht, and ht is defined as f convolution g. So you have f, you have g, so convolution of f and g will give you inverse of hs. And convolution we define this way. I already told you the definition. Let's see it again. 0 to t f tau g t minus tau d tau. So this is some variable, and this t is some variable. So we'll write this, and this will give you convolution, and this will be equal to inverse of hs. So we'll see the application part, means with some examples, that it will be more clear to you. Means L inverse of hs equal to ht, as I already told you, and ht is equal to convolution of f and g. So if you can find the convolution of f and g, that will give you the st. Or you can just take Laplace transform of L will be equal to hs, and hs is nothing but fsgs. So from here you can see that L, Laplace transform of fg convolution fgt will give you hs, and hs is fsgs. So if you know this, so you can just calculate directly. Let's see some properties of convolution. Then you will see some examples. Then you will see that what is convolution is. So convolution of fg is equal to gf, so means it is commutative. And convolution of f with g1 plus g2 is equal to f convolution g1, f convolution g2. This is distributive property. Then associative property fg convolution with v equal to f convolution with gv, that is associative. Now f convolution with 0 is 0 convolution f equal to 0, and f convolution with 1 is not equal to f in general. It can be equal to f, but in general it is not. So let's see one example based on this, then it will be more clear. We have this, we need to find the inverse of this, inverse Laplace transform 1 upon s square plus 1 whole square. So we can write this as 1 upon s square plus 1, s square plus 1, s square plus 1. Now let's say this is fs, this is gs. Now to find the inverse of this, how can we do that? Means we know this is fsgs, this is something hs, so we need to find this inverse. Inverse is equal to ht, and ht is nothing but convolution of f and g. So we just need to find the inverse of this separately and this separately. This will give us f and g. So this will give us sin t, and this will also give us sin t. So f g dt equal to sin t. Now just find the convolution that will give you inverse of this complete function, because this is fsgs. Now let's say how can we find the convolution? Convolution is f tau g t minus tau. If this is your, let's assume this is first is sin t, that is our ft. So we just remove t with tau, so it will be sin tau. Then gt is also sin t, that will removed by t minus tau. So sin t minus tau d tau. Now limit is 0 to tau t. So now here we'll use the identity. 1 upon 2 means 2 sin a sin b is equal to cos a minus b minus cos a plus b. So 1 upon 2 and 2, that will give us cos a minus b. There is tau minus t plus tau, it will be 2 tau minus t. Then minus sin a plus b, that means tau will cancel out, it will be sin t. And sin t, sorry, cos, it is 2 sin a sin b is equal to cos a minus b minus cos a plus b. Na? So it is cos a minus will give us 2 tau minus t, and cos a plus b will give us cos t. Now we will integrate separately. So you know how to integrate. This will give us this for the limits. This will give us minus 1 upon 2. And see, this is not a function of tau, and this is cos t. So cos t is constant here. We are partially differentiating, integrating. So it will give us tau here, and it will be t minus 0, and that will give us t. Now here also only this tau part is integrated. This is some constant for this. And after substituting the limit, you will get this. So this will be your inverse of this. So that's how you can find the inverse using the convolution. Let's see one more example. 1 upon s square minus s, 1 upon s square s minus a. So we also can write this as fsgs. So fs is 1 upon s square, and fgs is 1 upon s minus a, and this is the product. So just find the inverse of this separately, that is t, and separately this for it is eat. And now the convolution of fg will give you the inverse. So let's find this is, if this is your ft, then place tau here, it is tau, and here it is t minus tau, so you will write e exponential a t minus tau d tau. Now this eat will be outside because this is constant and tau is variable here. So this will be your integral. Now you just use the integration by parts, so that will give you the integration. And just put the limits and you will get your inverse. This will be your answer. Let's take one more example. We need to find the inverse of this. So again, we can assume as fsgs, and inverse of fs is ft, that is sin t, and gs is gt, that is c cos t, c cos 2t. You know how to find the inverse. So separately you have now convolution of ft will give you the inverse of this complete. So convolution again, this is ft, so it will be removed by tau here, so sin tau. Now it will be removed by t minus tau, it will be t minus tau. Now we'll use identity. 1 upon 2 means 2 sin a cos b, that is equal to sin a plus b plus sin a minus b. So use that identity, this will be this, and just substitute the limit, and this will be your answer, cos t minus cos 2t. Now there is one more thing remaining here, that is Laplace transform of periodic function. If ft is some periodic function, then how can you find the Laplace transform of that function? So LFT is nothing but 1 upon, this is the formula you must remember, 1 upon 1 minus exponential minus ps, where p is period, 0 to p exponential minus st ft dt. So let's take an example, you must remember this. So let's ft is given sin omega t from 0 to pi by omega, It is 0 from 0 for pi by omega to 2 pi by omega, and period is given, that is 2 pi by omega, means 0 to 2 pi by omega, this will be the function, means 0 to pi by omega, this is sin omega t, and pi by omega 2 pi omega, this is 0. And now the period 2 pi by omega, means this thing will repeat up to here, this thing will repeat. Now this will be like this. So this is something like half wave rectified. So this is your function and this is your graph, and you have the period. So in place of p, we'll write 2 pi by omega, and we'll just integrate this, and that will give us the Fourier transform of this periodic function. So 1 upon 1 minus c minus ps, this is the formula. So in place of ft, we'll write sin omega t, and limit will change to 0 to pi by omega, because from pi by omega to this, it will be 0. Now here we will use this identity. We already know this identity. You must remember these formulas. Exponential ax sin bx dx is equal to exponential ax by a square plus b square. Sorry, this is the integration actually. Is the integration sign also there? This integration is equal to this ax divided by a square plus b square is sin bx minus b cos bx. So this integration can be directly solved, and just substitute the limit 0 to pi by omega and try to solve. So you just solve this. This is a very easy problem. So here we will reach. Now see, this can be written as a square of this e minus pi by omega s square. So it is 1 square minus this. So a plus b, a minus b. This plus part will cancel out and only the minus 1 will remaining. And this will be your Laplace transform for that periodic function. So here we just substitute the limit and solve this, nothing more. Now see, if it was a full wave rectified, means if there was also wave here, then what happens, means the period will remove to pi by omega, because then it is repeating after pi by omega. So when the period is pi by omega, so only the p will change and everything will remain same. And try to solve this, you will get this result for p equal to pi by omega. Fs equal to omega by s square plus omega square, e pi by 2 omega s plus e exponential minus pi by 2 omega s, and this. So now you can divide by 2 in the both upper and the numerator and the denominator. So then the numerator you will get, this is nothing but cos hyperbolic pi s by 2 omega, and this is sin hyperbolic pi s by 2 omega. So this is cos by sine will give you cot hyperbolic pi s by 2 omega. So omega by s square plus omega square. So this will be your solution for the full wave. So you must know how to find this. So that's it. Here we end our Laplace transform and the Fourier transform. In the next, only the thing is remaining is Green's function. So we'll see. In the 2 lectures it will be completed. Then our complete mathematical physics will be completed. Thank you everyone.